Let's continue with chapter 2.1 and the topic of sets. And so we're going to look at some definitions with sets. Remember, sets, going back to our definition, is a collection of objects, right? And these objects have some characteristic in common. And so we're going to apply these definitions to these sets. And in our case, we're going to be talking sets of numbers, whole numbers, natural numbers, fractions, decimals, things like that. But let's look at the language, official language of sets. So we will say a set has one-to-one correspondence, right? If the number of elements in one set matches up to the number of elements in another set, then we say there's a one-to-one correspondence. And so we can look at the definition. If there is a one-to-one correspondence between sets, we write this. We use that symbol to say those sets have the same amount of objects. And we say A and B are equivalent or matching set. See how they match up with each other. Now, you got to be careful. Two equivalent is not the same as equal. Two sets are equal, right? If and only if the sets have the same exact element. So be careful of that language between equivalent and equal. Equivalent or one-to-one means they just match up together. Equal means they have the same exact elements. We're also understanding that sets can have what we call subsets, like a small group from a bigger group, right? And so a set A, here's a set, here's B in this case, and we can say A is a subset of B because you see A is inside of B. Every element of A is also in B. That's called a subset. There's also, again, formal language of something called a proper subset. And in this case, if A is a subset of B and B has an element that's not in A, meaning B is bigger than A, we can write A as a subset of B. That little line is kind of like it's an equal sign, but again, it's a technicality, but you want to be aware of that you can have subsets and something called a proper subset, meaning that it is smaller than this bigger one. AB is a subset or a proper subset of ABC. The reason we make the distinction is that officially, we also can say that AB is a subset of ABC, right? C is in the second, but not in the first one here. The reason we would want to say something like that would be, if you want to get this example down, is ABC is not a proper subset of ABC. It is a subset. I would have to use that line there like the equals, right? That's different than this one that I could write either way. With that. So you want to be mindful of that. And then a quick, if we're in class here, quick think, pair, share here, or think about a set of numbers that is a proper subset of another set of numbers and then share with others. So think about that real quick and I'll put one down. And so one way that I would think about this is we'll start with natural numbers, right? What are natural numbers? We'll go over that again too, but officially they're the numbers from 1, 2, 3, all the way, right? Continuing on, 3, 4, 5, and 6, continue on. Those are the natural numbers, what we call natural numbers. 3, 4, dot, 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 go on forever. And then let's go with odd numbers. This is just one example. Odd numbers are 1, 3, 5, dot, 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 right? And so in this case, I would say that odd numbers are a proper subset of natural numbers, right? And so that was what we could do there. So again, that's our formal language of of these definitions and how we think about sets and how they're related to each other. I want to just again make sure, again, as you see these pictures here, you see that we use Venn diagrams many times to distinguish sets. And so I can see that this set is inside of this set, and then the B set is inside of the which is called the universe, right? So the way to think about it is a city is inside of a county is inside of a state, a state is inside of a country is inside of the world, and the world's inside of the universe, right? You have that relationship, and you can represent that with a Venn diagram there.